In the prior section, we created confidence intervals using the empirical rule because we were able to add and subtract the appropriate amount of standard deviations or standard errors in order to create our margin of error and move from that center value out and create these intervals. But of course, not everything is going to fall perfectly on one of those three empirical rule values of 68, 95, or 99.7%. We a lot of times may want to create an interval of a 90% confidence level, or maybe just a 99 or an 80%. So how do we do those? We need to use technology to help us. The first skill we're going to look at is finding the z-score for a given confidence level denoted CL. So what we know is that the confidence level is the area in the middle of the standard normal distribution. So these areas that are in between here, whenever we write our percentage, how much we want to be included inside there, that's the confidence level. So again, we can use other values other than these. We can use any percentage we want. What that does then, since that's the area inside between these two z values, is it creates tails, and that creates a complement. So the confidence level, the area inside this curve, is the complement then of whatever area is left outside of these curves. The area outside of these values is denoted as alpha. So the confidence level and alpha are complements. And this is just by definition. So anytime you have the confidence level, you can find an alpha value by simply doing 1 minus. And same with the other way around. If you have an alpha value, you can do 1 minus to find the confidence level. You can move back and forth between those given 1. In this case, whenever you have the two-tailed situation happening, this alpha value then is the non-shaded area that's split up equally between the two tails. That means each tail will have an area of alpha over 2. The z-score that has an area to the right of it of alpha over 2 is donated by z sub alpha over 2. And this is the z-score you need if you're going to create a confidence interval. So that z sub alpha over 2 is this z value right here. It has an area to the right of alpha over 2. So that's what we're going to be finding. So our steps are going to be, we're going to be given a confidence level, CL. We're first going to use our complement rule to find the alpha value that goes along with that. Then we are going to calculate the probability, or the shaded area under the normal curve, by using this formula. That probability equals 1 minus alpha over 2. And then we are going to jump over to Excel and use the norm.s.inverse command. This is the inverse of a standard normal command because, again, we're finding z-scores, which means we're working in a standard normal curve. So let's see how one of these works. Let's find the z-score that corresponds with a 90% confidence level using Excel. So there are a couple calculations we can do first before hopping to Excel. One is that we need to find that alpha value. Again, alpha equals 1 minus the confidence level. So in this case, 1 minus 0.90, because the 90% is our confidence level. So our alpha value is 0.10. Next, we're going to find the probability by doing 1 minus alpha over 2. So 1 minus 0.10 divided by 2, or 1 minus 0.05, which is 0.95. Now is where I'm going to jump to Excel. I'm going to type in equals norm, N-O-R-M, N-O-R-M dot S or you can choose it when it pre-populates. And this command only accepts a probability. So we have the probability to put in there 0.95, and it is going to tell us that value. So I'm going to hop over here to my Excel now. Equals norm dot and s dot inverse, our INV, comes up. I'm going to type in 0.95 in this case and hit enter. And the value that I get, so the z-score that I get of alpha over 2 in this case is, I'm going to say 1.645. I'm going to keep 3 decimal places. So that's what we get there. And the cool thing about these is that every time you get a 90% confidence level, you would go through these exact same steps and you would always end up getting this same 1.645 z-score. Every time you do an 80% confidence level, the z-score should come out the same. So as you work on these in your assignment, you'll probably start almost just remembering a few of the very popular confidence level z-scores that are associated with them. Okay, so let's see. After calculating the z-score, the next step, the next thing we want to be able to do is calculate the margin of error. So we start the same way. We can still find alpha by doing 1 minus the confidence level. In this case, for finding the margin of error, we next need to identify, we have to be given it in a problem, that we will have the population standard deviation and the sample size in. So you have to be given those values, and then you calculate the alpha. Then we're going to hop over to Excel and use the confidence.norm command, input these 3 values, and that's going to give us our margin of error. So let's see how that works. So suppose scores on exams in a statistics class are normally distributed with an unknown population mean. So we do know that we're working in a normal distribution. We don't know what mu is. We don't know the population mean, but we do know the population standard deviation is 5 points. So we do have that sigma is 5. A random sample of 92 students' scores is taken. So that's our in value, 92. And the sample mean is 73. So I'm just labeling everything as I go. Sample mean is denoted by X bar, so that's 73. We want to use Excel to find the margin of error for a 90% confidence interval for this population. So I'm going to look back at my steps here. The first thing I need to do, again, is find that alpha value. So alpha is 1 minus the confidence level. So again, in this case, 1 minus 0.90 for 90%, or 0.10. Step 2 says to make sure identify the sigma and the in. So we already have those. I've already denoted those. Sigma is 5, we said, and in is 92. So all that's left is to go into Excel and use our equals confidence.norm command. And it takes the values alpha, comma, sigma, comma, in. So let's see, alpha is 0.10, sigma is 5, in is 92. This is how we calculate the margin of error. So let's see what Excel tells us. In this one, I'm going to skip over here a little bit. So equals confidence.norm. We've got to put in 0.10, 592, and we get 0.857. Okay, so now let's do the same steps. The only difference is we're going to do it for a 98% confidence interval, or for our confidence level. So it should work mostly the same. My first step is still finding alpha, so 1 minus, this time though, 0.98, so that's 0.02. Sigma's still 5, in is still 92. So when I go into Excel, it's going to look very similar. So confidence.norm. The only difference is I'm putting in a 0.02 here. So let's see what Excel gives us. And we should be thinking, we should know sort of what to expect. We just bumped up from a 90% confidence level to a 98. So we're being more confident in what we're saying here. More confidence should result in a larger margin of error and a larger interval overall. So let's see if we get what we're expecting. Do we get a larger margin of error here? Oops, I'm typing what I'm saying instead of what I should type. Okay, so confidence.norm again, this time 0.025 and 92. And what happened was what I expected. In this case, we get 1.213. So our margin of error did get larger when we increased our confidence level.